going through part 2 of the practical electricity for your O level. So, sources of errors and precaution. So, namely, there are 4 types: your mechanics, meaning your forces, and then our moment. Next, thermal physics, light and electricity and magnetism. So, let's look at the first one. Okay, so these are the list. This is the list of the errors that is possible for mechanics. So for example, measuring dimension of an object. So let's say if the object that you're trying to measure is not uniform, for example, like a wire or a sphere or a rod, an iron rod. Okay, so what's the precaution? You should take multiple reading at different location and then take the average value. And then of course, you can also mention take reading vertically to prevent parallax error. Okay, but ideally you should mention the first one. Okay, try not to give the generic one unless you really can't think of a better sources of error. Next one, stopwatch. Okay, so whenever you use a stopwatch, you should have the experience. Is sometimes it's like no clear signal to start or stop the stopwatch. Okay, or human reaction time. So for this error, what can you do? Introduce a better indicator. Okay, start the stopwatch when the pendulum is at its extreme end of the swing. Okay, because when it's at the extreme end of the swing, right, the speed will be the slowest, so it's easier for you to identify. Or for human reaction time, modify the experiment so that a longer duration is recorded. For example, take the time for 20 oscillation instead of 1 oscillation. Okay, then you can take the average. Next one, oscillating object. So what if there's a wind blowing? Okay, this might be a source of error. So you can close the window and switch off the fan. I'm sure you have this experience before when you do the experiment in your school lab. Or the next one, the oscillating motion is not steady. Okay, so meaning when you release the pendulum, right, initially the swinging motion is not steady. Okay, so you should only start the stopwatch when the swinging motion is steady, or you can ensure the hole made for the pivot is small. Okay, so the needle passing through the hole, make sure it's small and not too big for the needle to pass through. Okay, if not, the swinging motion might be irregular if the hole is too big for the needle. And then of course, reduce the amplitude of oscillation. Amplitude basically means the angle where you displace the pendulum and release. Okay, do not display it by too large of an angle, then you release. Maybe about 10 degrees. Okay, should be good enough. Okay, then next one, when you try to balance object at pivot. So this one usually is for moment experiment. So what's the error? Pivot may not be placed exactly at the CG, center of gravity. So how do you ensure this error is being eliminated? Okay, so the precaution, ensure the height of both ends of the meter rule from the bench top are equal. So basically you put the pivot at the 50 cm mark. So from the 0 cm mark to the table, you can measure what's the height, and then from 100 cm mark to the table, you can measure what's the height. Try to make sure that both height are about the same. So if they are about the same, means your meter rule will be horizontal. Okay, or of course you can close the window or switch off the fan, because when the wind is blowing, it might cause your meter rule to oscillate about the pivot. Okay, so just memorize this one before you go for your exam. So because usually at the last part of the experiment, they will ask you what are the sources of error and how you do your precaution. Okay, next one, thermal physics. So once in a while you might get it, but not that often actually. But just go through a fast one. Measuring of temperature using thermometer. So sometimes when you measure thermometer reading, even for chemistry and practical, okay, the temperature reading might be fluctuating. Okay, so what are the precautions? So you have a few here. First one, take the temperature reading only after the temperature remain relatively constant. Okay, so once it's stabilized, then you take the reading. That will be the accurate reading. Okay, next one, the thermometer should not be touching the side of the container. Okay, so you don't want any heat loss to the surrounding or to the container. This one is very important. The bulb of the thermometer must be fully submerged into the solution. Bulb basically means the lowest part of the thermometer, so it must be fully covered by the solution. Okay, so you can measure the temperature of the solution accurately. This one, the generic one, read the thermometer reading at the same level to prevent parallax error. Okay, so this one you learn in Sec 1 and Sec 2. And then this one, of course, do not stir the solution with a thermometer. Instead, use a glass rod. Because when you stir it with your thermometer, right, there might be friction, then it might cause the thermometer to measure a higher temperature than the expected one. Okay? Next one. So when you try to transfer object from the source to the object, okay, so there might be heat loss to the surrounding or heat loss to the container. Okay, so ideally you should insulate the solution in a styrofoam cup. Means you pour the solution in a styrofoam cup and then place it in a beaker. I think this one most students have tried it before in your chemistry maybe. Okay, so these two are for your thermal physics. Next one. For light, okay, light is quite common, okay, so whenever you use glass block, okay, the glass block might shift from the original position during experiment. So usually your experiment, they'll ask you to trace out the position of the glass block on a piece of paper. So sometimes when you do the experiment, the glass block might shift, so you can use what, blue tack to secure the glass block onto the paper, okay, so to prevent it from shifting. Because once you shift the glass block, it's very hard for you. Sometimes it might be a bit troublesome for you to put back into the exact location. Okay, so next one, when you use optical pins, means the pins to align them. So this one, the error, size of the holes created by the optical pins are too large after repeated piercing through. Okay, so ideally place the optical pin far apart from each other or try to pin it at a new location, but most important, it must still be far apart from each other. Okay, so that the accuracy will be higher. Okay, or sometimes difficult to determine the alignment of the optical pins accurately. So to do this right, you should place the optical pin far apart from each other, at least 5 cm apart. And then if you have tried this experiment before, sometimes the pin when you insert to the softboard, right, it might be a bit slanted. So ideally, if possible, you should use what, a set square to ensure the optical pins are perpendicular to the paper. Okay, so maybe initially when you pin it, it's a bit slanted, then you try to see it from the eye level. Okay, then if you realize it's a bit slanted, the pin, so you can use a set square, place it on the softboard, and then you pull out the pin and pierce it through again, in this case perpendicularly. Okay, next one, so user of mirror, so quite common also. So the mirror might shift from the original position, very similar to the glass block, so you can use blue tack to secure the mirror. And then most important is what, so if you're observant enough, the mirror, okay, there's one face of the mirror is actually the silver surface, that is your reflective surface. Okay, so this reflective surface should be placed on the line that is drawn to represent the reflecting surface. Okay, not the front of the mirror, but the reflective surface of the mirror should be on the line. Okay, so this one try to take note, very important, because sometimes your mirror will have some thickness. Okay, so do not align it to the front of the mirror, align it to the silver surface of the mirror on the line. Very important, this one. Okay, and then of course, once in a while you might use converging lens. Okay, so you put it on your lens holder. So difficult to determine the sharpness of the image accurately. So usually for this type of experiment, you need to shift your lens backward and forward until you see a sharp image on your screen. So to solve this issue, right, you can dim the surrounding brightness. Okay, so usually you switch off the light in the laboratory. Okay, or difficult to determine the distance from the center of the lens to the screen accurately. Okay, so you try to measure the image distance. So try to fix the lens upright in the lens holder using plasticine, because sometimes the lens holder, right, might be too big for the lens, so the lens might be a bit slanting or like facing downwards. Okay, so you should always make sure your lens is upright, so you can use plasticine to secure it. Okay, make sure it's vertically upright, and then also try to align the object at the same level as the center of the lens. Okay, sometimes the object that gives out light might be a bit higher than the lens. Okay, then you won't get the image on the screen. So try to lower your object until it's the same level as the center of the lens. Okay, everything must be aligned. Okay, the object to the center of the lens. Then you will see a clearer image. Okay, so it's easier for you to measure. Okay, so this is for light. Last one, electricity and magnetism. So one of the easiest one for electricity and magnetism circuit. Okay, so electricity, right, so the connection between electrical components and wires are loose. Okay, sometimes if you didn't connect properly, the connection might be a bit loose, or sometimes the battery use is not ideal and has some internal resistance. Okay, usually is ignore, but in practical, sometimes the resistance of the battery might have a significant impact on the reading itself. Okay, so make sure you tighten all electrical connection before you even start taking your first reading. Okay, so make sure the connection is all tight from like the wire to the resistor, or from the wire to your voltmeter or ammeter, or even to the battery. Make sure it's really there's a physical metal to metal connection. Okay, not just loosely connected. Then next one, when you use resistant wire, so this one you all should be very familiar with it. Okay, so you have some experience with this. So the jockey, okay, some students will press the jockey press too hard onto the resistant wire. Okay, so you should try to apply equal pressure when using the jockey on the resistant wire. You do not want to deform the cross-sectional area of the resistant wire, because what you learn in theory, if the cross-sectional area is changed, the resistance of the wire will be affected. So remember the formula R equals to rho L over A. Okay, so your area will affect the resistance of the wire. Okay, so on the resistant wire, next basically means like there's a small bends or small bumps, means the resistant wire is not parallel on the meter rule. Okay, so or sometimes the cross-sectional area of the resistant wire is not uniform. So if that's the case, right, you should try to ask the lab technician to replace your wire, or if there's needs, right, you try to press it or straighten the resistant wire before the start of the experiment. You want to ensure that your resistant wire is completely flat on the meter rule, okay, because that will affect your reading. And then of course, this one's very, very important. The resistant wire gets heat up during the experiment. Okay, so ideally, because you know that from your theory, if the temperature increase, right, the resistance will increase accordingly. Okay, under your Ohm's law. So ideally, you should switch off the circuit after a reading is taken. So whenever you place the jockey and you read off the reading from your voltmeter and ammeter, right? Okay, before you even record down onto your paper, you should switch off first. Okay, you do not want to overheat. You do not want the current to be continually flowing in the circuit while you are writing down the value in your foolscap paper or exam papers. Okay, so that's the stage. Okay, so first variable is what? You need to mention what's the independent variable and the dependent variable in your report. Okay, so sometimes you might need to use linear law from your AMATs to rearrange the given equation into this format, y equals to mx plus c. So the reason for doing that, so that you can identify which one is your y-axis variable and your x-axis variable. Y-axis variable means y, and then your x variable means x here. Okay, and then as well as your gradient and y-intercept. So your gradient in this case will be your m, and your y-intercept will be in c. But in the question, c might be in terms of some other variables. Okay. Second point, it is important to list out a few constant variables that will be kept constant to ensure a fair experiment. Okay, so usually you can mention 2 or 3 variables. Third point, you need to mention the steps. Okay, list out the steps to show how you will vary the independent variable, meaning how you will change your x value in order to obtain 6 values of dependent variable, meaning your y value. Okay, you change your x 6 times to get 6 different reading for y. Next, okay, you need to describe the relationship between your x and y axis, meaning mention to plot y axis variable against x-axis variable in a graph. Okay, so you try to tell them, you try to plot what against what variable. Next, after you have your graph, okay, you need to obtain your gradient or your y-intercept. Okay, so show how the gradient or the y-intercept of the graph can be used to find the unknown constant mentioned in the question. So sometimes the constant that they are interested in might be inside the y-intercept, or sometimes it might be in the gradient. Okay, sometimes it might not be directly equals to the gradient. You have to times 4 pi or divide by 4 pi, okay, depending on what the equation is. Okay, so you need to show the relationship, how you use the gradient and link it to the constant that they are looking for. Okay, so these are the 5 important points for your experiment planning. Okay, next, just to let you all know, in case some of you are interested, okay, so your practical, right, is 1 hour and 15 minutes, so it's 40 marks in total, and is the total weightage is what, 20% of your overall O-level results. Okay, so make sure you secure the 20%. Next, just now, your paper 3 is 1 hour and 15 minutes, so it's 40 marks in total. There are 2 sessions, so the first part, 20 marks. Okay, so usually it consists 1 or 2 compulsory practical experiment questions. So most of the time it will be just 1, okay, or depends, it'll be 1 or 2 small one maybe. Okay, and then for section B is another 20 marks. It will consist of your compulsory 55 minutes practical question. Okay, so usually this is the planning part. Okay, so in total will be 40 marks. So 55 minutes plus 55 minutes will be 1 hour and 15 minutes. So take note of the time, okay? So try to divide your time equally and don't spend too much time on an experiment, then you have not enough time for your planning, okay? So that's all. So don't forget to like, share and subscribe. Okay, bye.